Every so often, a single idea comes along that just changes everything. Back in 2017, 8 researchers published a paper with a title that sounds almost, well, simple. But its impact? It fundamentally reinvented how we think about artificial intelligence. This is the story of that paper. Attention is all you need.
To really get why this paper was such a big deal, we got to start with a really basic question. How does a machine actually read? I mean, how does it genuinely grasp the meaning of a sentence, all the connections between the words? For the longest time, the best AI models we had did this sequentially. They would read the first word, then the second, then the third, passing information along step by step. It's almost like a game of telephone. And that process, as logical as it might sound on the surface, turned out to be a massive, massive problem. A huge bottleneck that was slow, kind of forgetful, and it really put a ceiling on what AI could do. So, let's talk about this problem, the one that basically everyone in the field was trying to crack. We'll call it the sequential bottleneck. The top dog at the time was a technology called the Recurrent Neural Network, or RNN. And as the paper itself points out, their inherently sequential nature was the gold standard for language tasks. This was just how things were done.
Okay, so imagine you're trying to read a long sentence, but you can only look at it through a tiny little peephole, one word at a time. You can't see the whole picture, right? That's kind of how an RNN worked. It processes the word it's on based on its memory of the word that came right before it. This seriously limits how much you can do at once. And this created some major headaches. First off, it's slow. You can't just throw more computers at it to speed it up, because each word has to wait for the one before it. And second, they were forgetful. With really long sentences, the model would often forget the context from the beginning by the time it got to the end. The authors put it perfectly. The fundamental constraint of sequential computation remains. They were stuck. But the authors of this paper, they didn't just want to tweak the old method. They came up with a totally different way of thinking, a completely new kind of focus. They asked a radical question. What if, instead of that tiny peephole, the model had a bird's eye view? What if it could look at the entire sentence all at once and figure out how every single word relates to every other word all at the same time? And that's the big idea right there, self-attention. It's a mechanism that lets the model weigh the importance of all the other words when it's looking at just one. So take a sentence like, the robot picked up the ball because it was heavy. Self-attention lets the model instantly connect the word it all the way back to the ball, no matter how far apart they are. This was the absolute key. And from this one super powerful idea, a whole new kind of AI architecture was born. One that wasn't just using attention as a cool feature, but was built on it from the ground up. And they gave it a name that's now legendary, the Transformer. And here it is. This is the blueprint that basically changed the world. Now, don't get too bogged down in the details. Just look at the two big stacks. You've got the encoder on the left, which reads the sentence, and the decoder on the right, which writes the output. But notice what's missing? There are no sequential loops, no recurrence. It's all built on those powerful attention blocks we were just talking about. So, how'd they make attention so powerful? Well, they paralyzed it. The diagram on the right shows this brilliant idea called multi-head attention. Instead of having the model look at the sentence just once, it's like having 8 different experts analyze it at the same time. Each head focuses on a different part of the grammar or meaning, and then they combine their insights. It creates this incredibly rich, layered understanding of the text. Okay, but wait. If you throw out the whole step-by-step process, you create a new problem, right? If the model sees all the words at the same time, how does it know the order? How does it know the difference between, say, the dog chased the cat and the cat chased the dog? That's a huge deal. The solution they came up with was just beautiful. It's called positional encoding. Before any words even enter the model, they add a special signal to each one. It's a unique vector, a little piece of math that acts like a timestamp. It basically injects the word's position, its place in the line, directly into its data. Problem solved. So you've got this radical new design. It's faster, it's more parallel, but the real question is, does it actually work any better? Well, let's look at the results. They kind of speak for themselves. For the standard test, translating English to German, the Transformer didn't just squeak by the old record, it completely blew it out of the water. It hit a blue score of 28.4. That's an improvement of over 2 full points, which, in the world of machine translation, is a massive, massive leap. And this is where it gets really crazy. This table from the paper tells the whole story. The transformer didn't just get a higher quality score. Look at the training cost. It smashed the record while using a tiny fraction of the computing power. So it wasn't just better, it was also way, way cheaper and more efficient to train. That's a total game changer.
So why? Why was it so much better? Why is attention, like the title so boldly claims, really all you need? Well, the answer boils down to one simple but incredibly important metric.
Look at this. With the old RNNs, the number of steps it took to connect two words depended on how far apart they were. Computer scientists call that ON. But with self-attention, the path between any two words is always the same. It's one, just a single step, O1. That means it can connect the first word and the very last word of a giant document in a single operation. That's not an improvement, it's a quantum leap in efficiency. This quote from the paper's abstract really just says it all. You can feel the confidence. They weren't just adding a new feature. They were proposing to throw out the entire engine, the recurrence and convolutions that had powered the field for years, and just replace it all with attention. And the impact was just immediate and absolute. The transformer architecture, that's the T in GPT. It's the engine behind virtually all of the large language models that are changing our world today. This wasn't just another research paper, this was the starting pistol for a whole new era of AI. You know, the authors themselves were already thinking ahead, talking about applying attention to images, to audio, to video, which kind of leaves us with one last big question. If attention was all we needed to revolutionize language, what other incredibly complex problems are out there just waiting for this one powerful idea to come along and solve them?